Hello viewers. In this session, I will discuss about static routing and configuration of routers and switches. So without wasting any time, let's dive into the topic. So first, let's open the packet tracer. Now let's take the first diagram. Now for this network diagram, first we have to calculate the VLSM part. So let's move to the VLSM part. Here from the network diagram, I have wrote down the network address and I have wrote down the network address, the required host, the CIDR part. Now how to calculate the this block address. So now let's take one network address. Let's take it as 192.168.10.96. 192.168.10.96/30. So for this, firstly we have to calculate the subnet mask. So the subnet mask of this will be /30 will be, for first octet will be full, second octet will also be full, third octet will be also full, in fourth octet 6 bits will be on and 2 bits will be off. Now to calculate the subnet mask will be 255, 255, 255, 252. Now how do we how it is 252, how it is 252, which I have already explained in the subnet session, which is lecture 3. So the block address will be block address will be 256 minus 252, which is 4. Which is 4. Now to calculate the maximum host, the formula is two to the power n minus 2, which is 2. Now where n is number of bits. Now let's take another CIDR. Let's take it as in network 3, which is /26 192.168.10.0/26. First octet full, second octet will also be full. Third octet will also be full. Fourth octet will be two octets will be on, the rest will be off. So the subnet mask will be 255.255.192. Block address will be 256 minus 192, which is 64. Maximum host is 62. So for this network address 192.10.0/26, here the first host will be 192.168.10.1 and the last host will be 192.10.62. Here the first address and the last address, first address will be used for the network address and the last address will be used for the broadcast. Now let's understand what is the now let's understand how to calculate the hop count. The hop count is important as we have to know that when a packet moves from this one network to another network, how many a hop count a packet has to travel before it reaches from source to destination. So to understand the hop count, so let's understand this diagram. Here we have three routers, the router 1, router 2 and router 3. Now if we consider the router 1 as the source router and and when a packet moves from the router 1 to router 2, the hop count will be 0. When packet moves from router 1 to router 3, the hop count will be 1. Now if we consider the router 2 as the source, so from router 2 to router 1, when it goes, the hop count will be 0, and from router 2 to router 3, when it goes, the hop count will again be 0. Now if you consider the router 3 as the source, and when a packet moves from router 3 to router 1, the hop count will be 1, because the packet has to travel from firstly from router 3 to router 2, and router 2 to then to router 1 to reach router 1. Now when the packet moves from router 3 to router 2, the hop count is 0. Now let's calculate how so let's calculate the hop count for the for this diagram. Now if we take the the router 1 as a source, to calculate the hop count, firstly we have to write the network address, which is the router 1 the own network address. So here this we have done, they wrote the network address which is the router 1 own network. So here the hop count will be 0, because it is the router 1's the own address which the router 1 can clearly see. So here the hop count will be 0, and as it is directly connected to the router 1, so here it will be wrote as C. Now from the router 1, when a packet moves from router 1 to network 4, the packet has to move from router 1 to router 2, then from router 2 to network 4. So the hop count will be 1. And the exit interface will be serial 0/3/0, because when a packet moves from router 1 to router 2, the packet is leaving this interface as serial 0/3/0, because of which it is the exit the interface. And so when the packet moves from router 1 to router 3, it has to go to it has to pass from the router 2. So here the hop count will be 1, and similarly when it moves from to network 5, the hop count will be 2. Now if we consider the router 2 as the source, and when a packet moves from router 2 to network 3, it has to pass through router 1, so the hop count will be 1, and the exit interface will be serial 0/3/0. But when a packet moves from the router 2 to network 5, the hop count will again be 1, and the exit interface will be serial 0/3/1. So in this way, and we calculate the hop count for each of the routers. Now let's move to the router side to configure the router. Let's move to the CLI part. First command is enable. Then the command is configure T to move it to the interaction mode. Then we name the router host R1, assign the IP address *1, interface serial 0 by 3 by 0, IP address 192.168.10.101, and the subnet address. No cert is used to make the interface up. Now we have to provide the bandwidth. To provide the bandwidth, this is the command. Bandwidth is always used in the DTE side, not in the DCE side. Now configure the gigabit Ethernet port. Now let's move to the switch side, or router 1. Here the interface will be here the interface will be a VLAN 1. interface VLAN 1, interface VLAN 1, IP address 10.0, so it will be last address will be 10 dot the router 1. टेन डॉट जीरो स्लैश 26 10.62 26 no set to make it up. Now in this we have to give the default gateway in the switch. IP default gateway 192.168 10.1 control plus Z to exit, control plus Z, now let's move to the router 2. Enable config T host R2 interface IP address 192.168 10.102. Now you have to configure the second interface, which is serial 0 by 3 by 1. IP address 168 10.97. CubeSat, clock rate 64,000, clock rate 64,000, and then interface. Now it configure the Gigabyte Ethernet port. IP address 192.168.10.65 255 28. Now let's move to the switch part. Sorry, it will be host S2. Now interface VLAN 1, IP address 92.168.10. Last address will be 78. IP default gateway 68.10.65. Now let's configure the router 3. Address 192.168.10.65. make it active. Now let's move to the interface. G0 by 0 IP address 192.168.10.81. Make it active. Done. Let's close it. En config t host as 3 interface VLAN 1 IP address 92.168.10. Now we have to give the default gateway. IP default gateway 68.10.81. Now after configuring the router and switch, now we have to configure the routing table in each of the routers so that the packets can move from this one network to another network. To do that, let's move to the router 1 and give the routing table. En config t now to configure the static routing, the command will be IP root, then the network address, which is not of its own. So let's give the router, so give the network 4 address 192.168.10.64. Subnet mask 255.255.255. Then the exit interface. So the exit interface will be serial second command will be 192.168 to go to network 2. Network 2 will be 10.96 and it is 252, which is /30. Okay, it will be exact difference will be same, still 0/3/0. The third network address will be network 5. Network 5 will be 192.168.10.80. It will be 240, which is /28, because CIDR is /28 3/0. Now if we not save the configuration in the RAM, then each time the router is rebooted, the configuration will be lost. So to make the changes permanent in the router, we are giving the command as WR, write configuration. Now to see routing table, we provide the command so IP interface IP root. See the interfaces which are directly connected to the router 1 is mentioned as C, which is C is directly connected. S stands for static. So 190.10.0 10.0, which is the network 3 address, which is this its own network address, and the other network is 192.10.100/30, which is the own network address. So when it is connected to state 10.64, 64 is network 4. So here it is wrote as S. Similarly for 80, and similarly for 96. Now for the router 2, we provide the same commands. IP root, so from router 2 it is going to network 3. Network 3, which is the network address is 192.168.10.0 255 255 255 and 26. sorry, I missed the exit interface. Serial 0 by 3 by 0. Now another network address, which is network 5. Network 5 will be 192.168.10.80. Subnet mask will be /28 means 240, and the network the exit interface will be serial 0 by 3 by 1. As you can see, there are no other routes other than this, so we'll leave as it is. Now we check the IP route command. IP route brief. So IP route. Now let's move to the router 3. IP route from router 3 it is going to network 4, 192.168.10.64, 255, 240, and the exit interface will be serial 0 by 3 by 0. Now for second will be 64, then it is 10.0. Now the other is 10.100. Done. The right configuration. So IP route. Now let's provide the IP address in now let's provide a static IP to each of the PCs. To 168.10.1. Oh, so sorry, to 168.10.1. 10.2 10.3 10.1 192 168 10 dot 66 it will be 240 dot 65 10 dot 10 dot 65 68 10 dot 82 81 82 83 so now everything is configured and let's proceed with the Now let's see if the packets are traveling from one network to another network. So before we can proceed, first save the configuration in each of the router, switch and other, so as to not lose the configuration when if the router is rebooted or if any misconfiguration occurs. So now let's check. So when a packet is traveled from travel for the first time, the packet will just wait a minute. So when the first time when the packet travels, it fails, but after 2 to 3 attempts the packets move successfully. See,